Hi there, Serdar Yegodalp here for InfoWorld at IDG. In this episode of Smart Python, I'm going to take a look at some new aspects of the Cython project, a way to compile Python code to C for the sake of speed. Cython has been adding new syntax to make the language less jarring for existing Python users, and today we're going to take a look at how that new syntax works and how you can make it work for you. First, a quick overview of Cython itself. In previous videos, I've talked about Cython as a way to take Python code, add type declarations for it, essentially making your Python code use C types instead of Python objects, and gain significant speedups from doing so. The biggest speedups come from translating math operations on C types like integers and floats, or arrays of those primitives. Python doesn't deal well with you working with those things natively. Cython generates C code that does, and can run many times faster than its Python equivalents. Now, to use Cython, you have to write code using a syntax exclusive to Cython. Existing Python code will compile into Cython, but it won't show much, if any, performance gain. What's more, the syntax for Cython can be a little off-putting to Python users, since it harkens back to C itself. However, over time, Cython's creators have added an alternate syntax to Cython, one rooted in the way Python's own syntax works, such as its type hinting system. It's called Pure Python Mode. And while it doesn't yet fully replace the original Cython syntax, it provides us with two big advantages. One, you can write a functional Python version of your code using Cython's new syntax, and you can continue to run it as Python, even with the Cython declarations in it. This makes it easier to progressively accelerate your code with more Cython-specific syntax. Number two, you can continue to use your existing Python linting and formatting tools. Cython syntax meant formatting tools like BLACK and checking tools like Pyrite wouldn't function correctly. But the pure Python syntax for Cython means you can use those tools as you would for any other Python code. To demonstrate this, I'm going to show you examples of the classic and pure Python mode syntax side by side using the same project. This project, by the way, is a slightly revised version of the project that I used in a previous video to demonstrate Cython originally. It's an implementation of the mathematical game Conway's Game of Life, which simulates the life cycle of a colony of cells according to mathematical rules. And since it's highly math-intensive, it's a great candidate for being sped up through Cython. Here, we have the original Cython code for this project. And at a glance, it's pretty readable, even for someone who doesn't know Cython's custom syntax. And we can get code highlighting for it here in Visual Studio Code by way of a kind soul who wrote a Cython syntax highlighting extension. But we still have to wade through Cython's type declaration syntax and its funky custom syntax for declaring Cython objects like cdef, which is how we declare things like Cython functions. And even if we get used to all of that, we're still locked out of using all of our familiar tools for Python. We can't run BLACK to format this code, for instance, because the custom syntax will throw it off. Now, let's take a look at the same project written in Cython's pure Python syntax. Now, several things pop out right away. First is that this looks a lot more like actual Python. When we have type hints, they're in Python's regular type hinting format. And we use the Cython import up here to provide those, so they're not magic additions to the code. We can understand where they actually come from. Also, things like typecasts, which are commonly used in C and also in Cython too, are done by way of regular Python syntax, instead of the C-like casting syntax used in Cython, which is hard to follow and clashes badly with the rest of Python syntax. When we want to declare a Cython-level function or class, we don't use a custom keyword anymore, as we did in original Cython, where we used cdef. Instead, we take our function or class and we wrap it in a decorator, cython.cfunc to create a C-level function, and cython.cclass for a C-level class. Another really important difference is that we can use attributes in the imported Cython module to make decisions at runtime based on whether or not this code has been compiled to C. In this block here, we do this by checking the value of the cython.compiled attribute. If we're running a compiled version of this code, then we perform one set of imports. But if we're still in regular Python mode, we perform a different set of imports. And likewise here, later in the code, we make other decisions based on whether or not we're in compiled mode. If we are in compiled mode, all the non-compiled code branches will be automatically removed, so there's no performance impact when we compile to C. If we're still running in regular Python mode, the total impact for this amounts to a single if test. Now, you will want to avoid putting such tests in tight loops to avoid unnecessarily slowing down non-compiled code paths, but for the most part, this has very little impact. So here I've used this feature to make this code run in both regular unoptimized mode and in compiled mode. So this is a great way to prototype code in Python slowly and then accelerate it incrementally. This gives us our slow and our fast code paths for the same jobs side by side in the same code base. So let's run this code in regular unoptimized Python mode first. What you're seeing here, by the way, is the simulation of the lives and deaths of a colony of cells according to a set of mathematical rules. The flashes of red that you see are cells dying, the flashes of blue you see are cells being born, and the green is the cells that survive across generations. Now, unfortunately, the uncompiled version of this code is slow, very slow. According to the statistics I'm harvesting from the program in real time, it takes 0.04 seconds to render each generation, and around 0.027 seconds to draw that to the screen. If we want this to run at anything like 30 or 60 frames a second, we can't do this in regular Python mode. It just isn't going to work. We have to compile it. So let's close out of that version of the program and compile it to C. The compilation process doesn't take very long because we actually don't have that much code here. Cython works best when you use it to optimize a few small hotspots in your code that eat up the most runtime. With this program, things like the window and the input handling system are all still done in pure Python because they're not a significant source of the program's speed bottlenecks. All of that stuff is in the actual computation. So now let's run with the C-compiled version of this module. And first off, you can see how much faster it is just off the bat. The render time for each generation is several hundred times faster than it was before, as is the draw time. I'm running this program at 30 frames per second so that you can see it in this capture, but in theory we could run it at 1,000 frames per second. So again, the big advantages of pure Python mode for Cython are twofold. One, it lets us use the syntax and the tooling that we're familiar with through the rest of Python, both the current and the future versions. And two, it lets us do more of what Cython promises to begin with, which is being able to take regular Python code and speed it up bit by bit with type information and optimizations that only Cython can provide. Incidentally, there's been talk over the years about whether type annotations in Python would lead to a statically typed version of the language, one that could be better optimized for speed. My personal feeling is that we've had that for a long time in the form of Cython, and now with the pure Python mode for Cython growing that much more mature, we have it more now than ever. That's it for this video. If you liked it, please leave a comment below. Don't forget to subscribe to the IDG Tech Talk channel on YouTube. And for more Smart Python and more Dev with Serdar, be sure to follow me on Facebook, YouTube, and Infoworld.com.